Okay, I'm going to turn this roaster on, dry roast today. It seems like I have to turn it on twice, and it seems like that's a known problem with these ESP32 with the TFTs. So if it goes just a white screen, I just turn it off and back on again, and I'll click it the next time. And just get white screen. So back off. I might, if there's a change to the firmware, I might fix it. There we go. Alright, there's a lot more going on in this machine than there used to be. So, if you watched the other video, this is a ESP32-S3 development board with an expansion board so I can access the pins a lot easier. But I've got a 4-inch capacitive touch TFT screen with it. I've got a DS3231 real-time clock clone and the SHT31 ambient temperature it gives me the current temperature, which is on the screen. I got it in Fahrenheit and centigrade. It's 82.6 Fahrenheit or 28.2 centigrade. 54% humidity. And let's see. Also, we have a rotary push button encoder now. This is the EC11, and so I have two ways of pushing the buttons. I can select it with this. Select it, kind of highlights it. You can probably see it changing. Initially, I had it just to select the coffee roast. I had all the coffee roasts, all the particular coffees that I have on a text file on an SD card, and that just reads that text file and displays it through a list. So I'm roasting a Nicaraguan coffee today, and it'll be 4 ounces. And I also have a probe, different probe than I had before. This is 3 millimeters diameter by 100 millimeters, and I've angled there's a little bit of play in this, but since I've angled it like that, I can actually get it, gravity kind of works with me on that, so it doesn't really affect that looseness so much. But it should be right at the top of the beans. I used to have the thermocouple here, and I left that for now because I might put a second thermocouple back in there. And I'm running both the ESP32 and the motor. Well, the motor's running off of the ESP32. So I have the 5 volts coming off here with the buck converter on this portable power supply I made. This was somebody else's design, but I kind of modified it to use USB as well. Anyway, its first dry run test worked pretty good, so I'm pretty confident it's going to work pretty good this time. And I expect my temperatures to be well above 300 Fahrenheit. I used to only get up to about 250, 260 right up in this area, which is still pretty hot coming off of there. So I'm roasting 4 ounces, which I think is 113.5 grams. And we'll get started. I think this plastic is far enough away. It shouldn't get as hot. Especially with this angle, it should help dissipate the heat a little bit better than being flat. So if I'll actually turn the motor on, I just push the screen, and I'm set it to 120 RPMs, and this is a 5.18 reduction planetary motor on there, which I'm showing is 23.2 RPMs at the disc. At the 4 ounces, it just barely touches that sensor, so it's not going to be the exact bean temperature. And I did have a couple of glitches on the first run that I may have fixed from the firmware, but it like it turned the motor off one time, so hopefully it won't do that. So we're ready to start the roast. Oh, and I also have it saving the temperature every minute, and then it'll eventually save it to the SD card once it starts going back down again. Alright, let's see what it'll do. Heat is on, timer's on. Here's the timer. Yeah, timer's kind of a small letter. We probably should make that a little bit bigger so I can see it better. But it'll beep every minute. Alright, it's already up to 100 degrees Fahrenheit. Let's see if I can zoom in a little bit on that. Let me turn it off for a second while I just text underneath them. This probe seems to be a lot more sensitive than the other one that I had. Coming up on 5 minutes. Getting a nice brown. Should be first crack here in a second. I didn't hear it already. I think so. First crack. A little over 5 minutes. That sounds about right. And I'll run it pretty close to second crack. Second crack would give me a dark roast, and it'd be a lot oily beans. Ah, definitely hear that one. 338. Oh, yeah. 350 might be about the right temperature at that. Oh, the beans are hitting a little more since they've kind of expanded a little bit. I think this is going to work a lot nicer than the other one. Well, it already is, because I don't get any pause in the motor. I used to get a pause in the motor every second of the update of that old LCD display I had on the Arduino UNO. And I can display a lot more information on this display than I could the other one. Oh, let me see how. Yeah, it's slightly warm at the end. I don't know if I want to put my finger further in. I think this plastic's gonna be all right. Oh, I might have to stop it here. It's about ready to stop. What temperature I'm at? 369. Yeah, if we want to stop it. Alright, get in your way. back off a little bit. Long adjustment. I might have to zoom out. I just got a makeshift support for the fan. I usually have it on a glass table roasting, but I need a lower roasting platform to video it. I used to stop the fan blowing when they hit 100 degrees Fahrenheit, but since my probe was a lot lower, I might be a little bit higher temperature. I think this saves the data after it starts going down below 200 degrees, if I remember correctly. I'll take this off so you can see the roast. I'll point it at the roast so we can get a good picture of it. Actually, it seemed like the temperature went down a lot quicker. I think we're ready to stop the roast. Oh, now I can turn the motor off from either the button. I can see it. Let's see that. I can't see which one I've selected with this light. Alright, looks pretty good. It's a little bit darker roast than last time. I had 96.3 grams on the output. I had 113.5 on the input. Last time I roasted this, it was 98.6. Is that right? Yeah, 98.6 last time I roasted it. It looks pretty good to me. It's pretty close to dark. Really on the dark or medium maybe. I don't have a really good sense of what they are, but I know if it's really oily, it's going to be dark.